One of the most persistent and dangerous misconceptions in education is the belief that a test itself can be valid. According to the 2014 Standards for Educational and Psychological Testing, validity does not reside in the paper, the digital interface, or the specific questions. Assessment validity is actually a measure of accuracy. Specifically, it measures the accuracy of the score-based inferences and interpretations that educators make about a student. We are dealing with invisible targets. We cannot look inside a student's mind to observe their cognitive skills directly. Instead, we use their overt responses on an exam as visible proxies to guess what is happening covertly. When we mistakenly ascribe validity to the test itself, we start to believe it is universally suitable for all students in all contexts, leading to unsound educational decisions. The primary threat to making an accurate interpretation is assessment bias. Bias introduces elements into an assessment that distort a student's performance purely because of personal characteristics, like their gender, race, or socioeconomic status. When those external factors artificially depress or inflate a score, the inference we draw from that score is automatically compromised. Validity requires fairness as a technical baseline. Without it, the data yields no reliable insight into the student's actual knowledge. Assessment bias operates in two specific forms. The first is offensiveness. When a test presents negative stereotypes or slurs, it triggers an immediate emotional response. The resulting anger and distress consume the student's cognitive load. They are forced to process the offense instead of the academic task, which artificially lowers their score. Analytical. This illustration highlights the second, often subtle form of bias, unfair penalization. Notice the banner for slightly snooty suburban high. The test requires students to evaluate different types of caviar, placing the student on the left in a state of visible confusion. If a student fails this assessment, it isn't because they lack underlying analytical skills. They are failing because they lack socioeconomic familiarity with the subject matter. We see the exact same mechanism when a math exam relies heavily on obscure competitive sports analogies. It depresses the scores of female students who may be less familiar with those specific contexts, regardless of their actual mathematical ability. A penalty for failing to study is entirely fair. An unfair penalty punishes a student simply for belonging to a specific demographic group. This line graph shows performance distributions for two distinct demographic subgroups. When a high-stakes statewide test reveals a massive performance gap like this, the immediate assumption is often that the test is flawed. But disparate impact does not equal assessment bias. Consider a historical example. In the late 1970s, a southern state was field testing new accountability exams for high school graduation. The state assembled a review committee to evaluate the results. Roughly half of the teachers on that panel were Black. When the initial data showed Black students scoring significantly lower on certain items, administrators naturally assumed those specific questions had a disparate impact and needed to be thrown out. The Black teachers on the committee pushed back. They demanded the items remain because they covered critical, rigorous content that all students needed to know. The test accurately exposed a historical deficit in instruction, providing evidence of past inequities that the teachers intended to remediate. Psychometricians call this phenomenon a lack of opportunity to learn. Discarding test items purely because they yielded disparate impact doesn't fix inequity. It simply hides systemic instructional failures. To separate genuine assessment bias from a lack of opportunity to learn, modern test developers use a two-pronged methodology. The first layer is the judgmental approach. Panels composed of diverse representatives from the subgroups taking the test review the material under a strict directive. Reviewers are not asked if an item will offend or penalize. They are asked if it might offend. That deliberate, ultra-sensitive phrasing acts as an early warning tripwire. The second layer is empirical. Using an algorithm called differential item functioning, or DIF, statisticians sort the data, flagging specific outlier items where subgroups with identical overall abilities perform differently. DIF is powerful, but it requires massive sample sizes to work. And a flagged item isn't automatically biased. It still requires human review to determine whether the performance gap is due to flawed test design or an underlying instructional deficit. Algorithms can flag the statistical anomalies, but only empathetic human context can diagnose true bias. Historically, two specific populations were largely ignored in discussions of assessment validity: students with disabilities and English language learners. This changed in 1975 with Public Law 94-142, introducing the Individualized Education Program. But the landscape shifted radically with the 2002 No Child Left Behind Act, which disaggregated accountability data into demographic buckets, including students with disabilities and English learners. Under this law, if a school failed to make adequate yearly progress in any single subgroup, the entire school faced severe federal sanctions. While the legislation remains highly criticized, it forced educators to scrutinize the validity and fairness of how these special populations were being tested. Federal law gave psychometric fairness administrative teeth, requiring evidence of equity for every subgroup in every school. These strict principles of measurement shouldn't be confined to large-scale state testing. They must be applied directly to the individual classroom. Classroom teachers obviously do not have access to formal bias review panels or complex diff algorithms to evaluate their weekly quizzes. To compensate, teachers must build their own internal audit. They have to actively internalize the framework, asking, might this offend or unfairly penalize, for every single question they write. This is especially critical when dealing with performance assessments or tech-heavy assignments, where unexamined differences in a student's home resources can easily masquerade as academic ability. Protecting the validity of the inference ensures that the data reflects a student's actual growth, making measurement an essential component of educational equity.